Okay, question 3. We've got some apparatus used to investigate the melting of some crushed ice. So we can see all the ice in there. We've got a cable going to a data logger, and it's going to measure temperature over time. So that's really good. So this would probably be able to just produce us a graph of temperature over time. We've got an electrical heater. So we're going to heat up the ice and it's going to melt. Suggest one safety precaution when using the electrical heater. Just don't touch it. Don't ever say wear gloves. You probably get a mark for wear heat-proof gloves, but not for wear gloves. So do not touch the heater or use low voltages. Suggest one way of heating the crushed ice without using electricity. Well, I could have put a Bunsen underneath it, or I could put it in a water bath. Any sort of sensible answer of a different way of heating it without using electricity. Although I'd argue the water bath uses electricity. Anyway, it was in the mark scheme. So use a Bunsen burner or a water bath. A Bunsen burner is easy, isn't it? Just shove a Bunsen under it, heat it up. Question 6. So here we can see we've got our specific latent heat, and here we've got our specific heat capacity. So here we're heating it up and we're increasing the kinetic energy stores. And you know for that one we use Q equals MC delta T. And here we've got the specific latent heat where we're changing state, and for that we use Q equals ML. And we can see temperature increases because the kinetic energy stores increase. Then the potential energy stores increase here. So we've got increase in the potential energy stores. The particles are moving away from each other, so they've got some potential energy. And then after a while it's fully melted, and then the water heats up. So it's the ice, and here we've got that crucial idea that it's melting here. So at the start P, the beaker contains crushed ice. Describe what happens during the next 15 minutes. So P to Q increases, and I could say from 0 to about 4 minutes. So the temperature ice increases, we've increased the kinetic energy stores. Now we're going to talk about the next part, Q to R. So Q to R, the ice is melting from a solid to a liquid. The temperature stays the same. And if you wanted to show off, we've increased the potential energy stores. And then for the last part, we've now got the water, the temperature of the water increases, we're increasing the kinetic energy stores. So it's that idea. We increase the temperature, then it melts, then we increase the temperature. Increase the kinetic energy stores, increase the potential energy stores, increase the kinetic energy stores. Be good at that because it's come up a lot. The next one, we've got bubbles coming from a diver, and we can see that the bubbles get larger as they reach the surface. Which row is correct as one bubble rises? So we've got here B, the air pressure in the bubble decreases, the volume increases. So we know that there's more pressure as we go deeper into the water, and that water is going to put a pressure on the air inside the bubble, and here they're smaller, and then the volume gets larger because there's less pressure higher up. So B. Which of these is the unit for pressure? So we know that's newtons per meter squared, newtons per centimeter squared, and newtons per meter squared is equivalent to a Pascal. So we're looking for that, and that is D. The next one, it tells you exactly what to do. So it says calculate the volume V2, use that equation. So you don't even need to use your brain, you just got to put everything in. So that's in litres. We're just going to check all the units. Litres, perfect. 3.3 atmospheres, yeah, that's fine. Perfect. Atmospheres, perfect. So they all speak to each other, and then we can see P1 has to go in there, multiplied by volume 1, all divided by that. So it's just do exactly what it says, and you end up with, need a divide line there. So pressure 1, 330, multiplied by volume 1, 0.5, all divided by 1.07. So I think that's quite a nice question because it tells you exactly what to do. That's that done.